Hello and welcome to Session 4 of Technology and Best Practices. Today we'll be talking about testing water meters. Two main questions. How is a water meter tested? And what is the meaning of the error? Starting by the latter, like any other metering device on Earth, water meters have a reading error, and in practical terms, for a given volume of water, there is a metered value by the device. A bit like playing darts. Even if you're very good, it is difficult to hit the center spot over and over again. Different meters have different performances, of course, where the distance from the center is the precision, and the density of hits gives you an idea of the repeatability. So, testing. You're testing devices that operate between 0 cubic meters to the maximum flow, and traditionally you set between 3 to 11 and even more flow rates. Each flow rate corresponds to a target, and each test is repeated between 3 to 10 times. So, what does it tell us? Well, testing renders a general appreciation of a meter's precision, quality, and durability when associated with other tests. The way to visualize the quality of the test is through a precision graphic, or sometimes called an error curve. This 100% represents the real value. We have the nominal flow of the meter, its measuring range to the minimum flow, Q1 and Q3. These two flow rates determine the transitional flow and the maximum flow that bound the plus or minus 5% tolerance between Q1 and Q2 and the plus or minus 2% between Q2 and Q4. So testing. When we test a meter, we establish, in this case, 6 testing points or 6 targets, and we plot the results along these targets. When we join the different results, this gives us a curve. This curve is the visualization of the precision of the meter and therefore the quality under test. But how exactly is each flow rate tested? Well, it is a comparison of volumes that are read at a given flow rate, more exactly the delta between the reference volume and the volume registered by the meter. In this case, the blue line represents the tested volume, or the reference volume, that is determined at the given flow rate between time 0 and time 1, and the response given by the meter between the same timing. The delta between these two are therefore the precision or the error. That gives us error 1 for a specific flow rate, and we repeat the operation for a different flow rate. What it does not tell us. It does not say anything about the performance and the changing flow rates, opening or closing a tap, for example. It does not differentiate between the technologies. Meters are tested with permanent flow rates. The example with the static meter that operates based on flow sampling. Flow sampling means that the measure is taken every n seconds or milliseconds, depending on the technology. In this case, taking the time axis with the moment when the sampling actually occurs and with a consumption profile, the moment when the meter actually acquires the flow and the consequent curve that the meter registers and bills to the end customer. If we bring back the original curve, we see that there are some positives and some negatives that the meter has missed or added, which means that there is a meter operational precision in the end, or error, if you like. Now, comparing exactly the same meter but with a slower flow sampling, we see that the curve that is originated is slightly different, and therefore, when we compile the deltas, the performance is also a little bit different. When we put the results side by side, we note that the response is not exactly the same between our first example and our second example. So when tested with permanent flows on a bench, both devices may present the same accuracy, but nothing is said about their operational dynamic. As a conclusion of this session 4, depending on the purpose of the meter, if it's billing, control, etc., its application and the knowledge you have of the consumption profile of where it's going to be used, the network quality or the quality of the service, and specifically about its test results, you have to choose your meters wisely. And specifically, we point and advise to the static meters and the way that you select the static meters. Be very careful on the way that you select the meter and look at the sampling frequency it operates on. Not the sampling frequency during test, but sampling frequency during the operation while it's on the field. If you have any doubts or for any other thing, do contact us for advice. Hope you have enjoyed our session 4. Dare to leave your imprint See you on session 5. Thank you.